Amanda invests $500 monthly in a high-risk investment because it potentially has a high reward. The investment loses money during the first 6 months. Amanda tracks the total amount invested and the total amount lost over the first 6 months of her investment in a table. What is Amanda's investment worth? Should Amanda continue to pay into this high-risk investment? Justify your response. Okay, so we're wanting to know, is Amanda's investment going to provide a return to her? Is it worth it to keep in this, even though it appears that she's losing more and more money each month? And so what we could do here is we need to know the trend of these tables. So we could find an equation for each one by finding the finite differences. And then we could basically, if we took the principal invested and subtracted the amount lost, then we could see, is it going to be worth it? Let's go ahead and find the finite differences. Subtracting here, we first see that the delta x here, 6 minus 5 is 1, 5 minus 4 is 1. It goes by 1 every single time. And so that works. And then going for the principal invested here, 3,000 minus 2,500 is 500, and so on. And each one here subtracts to 500, which means that this will be a linear function. And so going ahead and finding m for our linear function. So m will be equal to delta y divided by delta x. Delta y here is 500. Delta x we already saw was 1, so 500 divided by 1 is just 500. And then the y-intercept is going to be when x is 0, so f of x is 0. And so then our equation will just be y equals 500x, and then b we just saw is 0. And then finding our investment lost, then we can go ahead and find the finite differences here. And so we see that 576 minus 525 gives us 51, and then consecutively here we have 93, 117, and so on. And so we see that these are not constant. Let's go ahead and find the second difference. Again, for the second difference, just subtracting in order between each pair, then we again do not have a constant difference. So let's go on to the third difference. On the third difference, we see negative 42 minus negative 24 gives us negative 18. Negative 24 minus negative 6 again gives us negative 18. Negative 6 minus 12 is negative 18. And the last one also is negative 18. And so we have a cubic function since our third difference is the same. So just a reminder for our cubic functions, then we have this table over here. So we know that 6a will equal the third difference, which in our case is negative 18. So dividing by 6 on each side, then we get a equals negative 3, because negative 18 divided by 6. And then 6a plus 2b is the second difference. That's between 0 and 1, going as x gets bigger, and so it's going to be 30. And so we know that 6a is equal to negative 18. 7 plus 2b equals 30, so adding 18 to each side, we get 48 equals 2b. Dividing by 2 on each side, we get b equals 24. And then to get c, then we know a plus b plus c will be the first difference between x equals 0 and x equals 1, which is 81. And so then a is negative 3, b is 24. Negative 3 plus 24 gives us positive 21, plus c is 81. So subtracting 21 on each side, then we get that c equals 60. And so with those three, then we have the last one, which is d, and that's our y-intercept. And so we know that d will equal to 0 because at x equals 0, g of x equals 0. And so let's go ahead and write out this equation. So we have g of x equals negative 3x cubed plus 24x plus 60, and that should be 24x squared plus 60x plus 0. So there's our function for g of x. Now that we have those, we want to know if we take everything that she makes, f of x, and we subtract g of x, then will that be a positive return on her investment? And so taking that, if we took f of x, so 500x, and we subtract g of x, then let's see what we get there. So just distributing out, we get 500x minus negative 3x cubed, so that'll be plus 3x cubed, and then minus positive 24x squared, and then minus 60x, that's just distributing the negative to each term. Then we get combined like terms, gives us 440x plus 3x cubed minus 24x squared. Writing that in standard form, we get, looking at this function, then we see that Um, we, if for this number of months, then it really gets a lot bigger than 500x because we've got a cubic here and it's positive, and so it's going to go up a whole lot faster than her initial equation of 500x. Let's also just verify this and look at a graph here. Put the two equations in our calculator. We want to see if the investment, which is y1, will end up being bigger than y2, which is 500x. And so we'll look for a curved graph for the x cubed equation and then a linear for the y2 equation. So looking here, we see that our cubic, which is the amount that she makes with investing, it really does shoot up here, which is about around 10 months. And then we see that the amount that she puts into the bank account continues to increase, but it's not going to increase as much as that investment if she leaves it in there a little bit longer. And so that gives us the final part of our answer. So let's go ahead and summarize. Using the patterns and the finite differences in the table, the amount of principal Amanda has invested can be represented as f of x equals 500x. The amount of loss Amanda's investment has experienced has constant third differences, and so it can be represented by the cubic function g of x equals negative 3x cubed plus 24x squared plus 60x. The worth of Amanda's investment is f minus g of x equals 3x cubed minus 24x squared plus 440x. The long-term prospect for her high-risk investment is good, since it is described by an increasing cubic function. If the table is continued, the investment loss eventually decreases, and the investment starts to make a profit after more than 10 months. Amanda should continue to invest if she plans to invest long term.